Hi, I'm Paul. This is Science That Sticks. Everything you need to know about metals. Roll the graphic. Hi there, I'm Paul. This is Science That Sticks. Today I'm going to talk to you about metals. I'm going to talk to you about their properties, chemical and physical, and I'm going to explain those properties in terms of metallic bonding. Behind me is a brainstorming session, a mind map, a series of ideas that are all linked to the properties of metals. A property of something is what characterizes it, what makes it special. Metals are particularly unique because most of the periodic table is made of metals. So let's look at some chemical properties. They can be reactive, they can form salts, they can be unreactive, they can form oxides. Now, that might seem completely contradictory. They're reactive and they're unreactive. Well, yes, that's true, because lithium, sodium, potassium are very reactive. They'll react with water, but gold, silver and platinum will not react with water. Most metals will react with halogens. All of them will react with fluorine, and most of them will react with chlorine and iodine and bromine. These are the halogens. So they can be reactive and they can form salts. When they're burned, some of them can form oxides. Gold doesn't, platinum doesn't. But let's have a look now at the physical properties. Well, the physical properties are that they are shiny. They are malleable. That means you can hit them into shape. They are ductile. That means you can draw them into wires. They are good conductors of heat and good conductors of electricity. They're mostly hard. Some of them have got high density, some of them have got low densities, and that's normally governed by the atomic mass. They can be sonorous, like bells. In other words, when you hit them, they ring. These are all physical properties. Let's have a look at metallic bonds now. Metallic bonds, similarly to ionic bonds, are very strong. They have an electrostatic attraction between the cation nuclei and the sea of delocalized electrons. To explore this and explain it in more detail, let's look at the diagram. I'm going to draw it out. I'll fast forward it, but it really helps for you to be able to draw it too. Okay, so let's look at this image once more. What you can see is I've put circles that represent the nuclei of metals. What they've done is that because in a metal they have a sea of delocalized electrons, it helps us to visualize those outer electrons that are in like a dissociated sea of electron density. In other words, they're not in the orbital. They're merely able to move in between the nuclei of the atoms, or at least the atom itself. And in doing so, that metal atom becomes a cation. Now, this doesn't mean that we write it with a plus or a negative charge, because the electrons are still present. But as the electrons are free to move, this gives rise to it being able to conduct electricity, because those charged electrons are free to move, and so they do. It is also the reason why solids conduct heat. That and the fact that the particles are really close together, so they can vibrate, and they vibrate onto others close by, knocking them to and fro, hence conducting. Now let's have a look at this. So we've got the cations. They have a sea of delocalized electrons all around them. This sea of delocalized electrons allows for a very strong bond, which requires a great deal of energy to overcome them, and therefore they have high melting points, high boiling points. Now, there are obviously some exceptions. So group 1 metals are very soft. In fact, actually, as you go down the group from lithium, sodium, potassium, rubidium, cesium, you'll notice that the boiling points get lower and lower. And the reason for this is because the atom gets bigger, and as the atom itself gets bigger, that electron in its outer shell gets further away from the hold of the nucleus, which means those forces that are holding the cations together are not as strong as they would be with lithium. But if you also then look at some of the other metals that we are used to in everyday life, for example, iron, copper, gold, we know that those all have high melting points. This is because they can lose multiple electrons in their outer shell, and they can have a greater charge. It's not just +1, they can have +2, +3, +4. Manganese can have up to +7 or even +8. That's beyond the scope of GCSE. That's all she wrote. Till next time, one and all, stay cool. I'm out of here.